All right, so I realized the last video was kind of intense, some of the AC/DC leading to this. Trust me, that's why I broke this into 2 videos. So to recap, our AC plate is pulling light ions out of from feeling the effects of this DC plate. So we select for small ions. And if we look at the DC plate is going to have a lot of trouble pushing heavy ions, really big fat ions, and so it's going to select for the heavier molecules. Now, if we look at this in terms of a probability versus weight over charge, if you weigh a lot, if you don't weigh that much, the AC current is going to affect you. So we have a high probability of making it through these quadrapoles, these 4 poles, DC and AC plates, if we don't weigh that much. But for the DC, we're actually going to favor the heavier weights ones. This sweet spot here is the M over Z that we measure. So the quadrapole here is there to filter out the ions by weight. What they end up striking is a detector. Now, there's a few different detectors, but typically work with a Faraday cone or a, what are they called? Photomultipliers. So, we take our molecule, we hit it with electrons, it fragments, these different fragments. Go through our quadrapole. We have our AC and our DC, and at the end there is a detector. Now, a Faraday cone, what happens is that these ions hit the cone. There is a potential difference between the top of the cone and the end of the cone, and what it does is it creates a cascade of electrons. And eventually this cascade of electrons is picked up by a voltmeter, and so every time we hit it, we pick up a signal. The more we hit, the more signal, the higher the intensity of the signal. So this is going to be how we measure the amount of charges. The other option is a photomultiplier-like setup. So what we have are a series of charged plates with a voltage across them. The ion hits the first one, knocks a few electrons, those propagate down the line. This is going to give us our signal. Now, what are we plotting? Well, practically, what we're going to do is we're going to sweep the N to Z range. So we're going to select really light fragments first, and then we're going to sweep up the heavier fragments, and we're going to go back and forth multiple times. And what we're looking at is for intensity versus M over Z. So what we're plotting when we look at a mass spec plot is the number of fragments that make it through the quadrapole filter at a given selectivity for the M to Z ratio. This is what you're seeing with a mass spec spectrum. What we are viewing is basically how many ions do we get for this given M over Z ratio. So in the next video, we'll talk about the analysis and what we expect to see in terms of a spectrum.